Okay, so here's the video for section 9.3, rotations of polygons. We've already again talked about rotations before. We did that back in first semester. But now we're going to again formally define what a rotation really is, how to construct one, how to work with one. So again, we've identified them and verified them as congruence transformations, also called isometries. Now we're going to draw them, and we'll draw them in the coordinate plane. Key concept, rotation. Rotation is kind of complicated because there's a lot going on to it. You have to first of all have a point called the center of rotation. That's where you're going to rotate about. Okay, and then once you have that, then you have to have an angle of rotation that tells you how many degrees you're going to rotate it. So whenever you describe a rotation, what you always have to do is you have to describe the angle of rotation, the center, and what directions. There's really three parts to a rotation. So you've got your center here, you've got your angle, it's going to be rotated, and then are you going counterclockwise or clockwise? And most of the times when you rotate something, you're going counterclockwise. And then there's this two-part definition here, and it's kind of there for a reason. It says, first of all, if the point is the center of rotation, then the image and the pre-image are the same point. So for instance, if point C were part of the rotation, since that's the point I'm rotating about, it isn't going to move. Which makes sense. If you stand in one place and you twirl around in a circle, you don't move any, you just spin around. However, if you're point A, you will rotate around this guy. And how you'll move is you'll actually move along a circle. Okay, and you'll keep that same distance the whole way through. So I can draw this little cheap generic circle real quick and kind of show you that. Actually, I went no fill. Can I do no fill? I think just white will do. Okay. So right here, this point, if I go to point A, what actually ends up happening is, and you can't really see it because it's covering it, but to get from A to point A prime, you're going to rotate along a circle to get there. Now, how we define that is you move the same distance from A to C as it is from A prime to C. You keep congruent. That's the radius of the circle. So you're going to rotate that distance around and move it on the path of a circle. So that's the two-part definition. Again, if the point is not the center of rotation, then the image and pre-image are the same distance from the center. And the measure of the angle of rotation formed from the center of rotation and image point is x. That's the number of degrees. So to describe it, A prime is the image of A after a 120 degrees rotation about point C. And if it doesn't specify, it means counterclockwise. So just one more time to make you write it down because it's so important. The direction that rotations are generally measured is in counterclockwise. So for instance, here's our first example. For the diagram, which description best identifies the rotation of triangle ABC around point Q? So you got this one in your notes, so you can take a look at it, see what you think, and then give an answer. Okay, so when you look at this, if you're really trying to figure out what a rotation is, how many degrees it is, what you simply have to do, and you have to do this for all of them really, but you have to connect a point, the original point, to the center. Okay, and then the point that's reflected to the center as well, and then you got to figure out what angle that is. Well, in this case here, hopefully it's pretty obvious it's a right angle. And then again, you got to remember you got to go counterclockwise to get there. So this guy was 90 degrees, and the shorthand for counterclockwise is counterclockwise, CCW. Okay. So that's how it works. And then again, what's really happening is I'm traveling along a circle with that radius. Same thing for B. For B, I would have to connect from B to Q and B prime to Q, and what would happen is this guy would rotate around that as well. And from C to C prime, same exact thing. 90-degree arc of a circle rotations. All right, now there are three basic formulas, and I'll kind of show them to you how it works for this section. But there are three formulas so that we're not constantly just doing this by drawings and using compasses and stuff, which I didn't even really do the compass. We might talk in class about that sometime. The first one is if you're going to rotate something 90 degrees. And again, it's always assumed counterclockwise. So that's what it is. Now, the directions are to rotate a point 90 degrees counterclockwise about the origin, multiply the y coordinate by -1, and then interchange the x and y coordinates. Well, interchange is just a fancy word of saying switch. So notice we had 5, 2, they changed the 2 to -2, and they switched the order, -2, 5. And I've got a little drawing here to kind of show you that. Yeah. Oh, wrong one. Okay. So right now this guy is at 0 degrees, isn't rotated at all, and the points are all the exact same. But the moment I move this to be a 90-degree rotation, okay, counterclockwise, they switch all the ordered pairs. 4, 3 becomes negative, becomes 3, 4, 2, 2, 2, 2. That doesn't switch because of the same coordinate. And then 3, 1 is 1 negative, is 1, 3. But the old y values, the 3, the 2, the 1, are now the new x values, and they're switched as opposites. And if I move this guy here, like down to this one here, say make him, yeah, like this, okay, this was negative 3.05, now it's positive 3.05. So it doesn't just make it negative, it switches the sign. So I'll put b back to a nice decent point there, right there at 4, 4, let's say. Okay. Now, if I'm going to do a 180-degree rotation, this one's actually really, really simple. All you do is just switch the sign of x and y, and it takes care of it, rotates 180 degrees. So 5, 2 becomes -5, -2. So multiply the x and y coordinates by -1. And here's the drawing of that happening. So if I go to the 180 degrees for this guy, 180 degrees, 4, 4, -4, -4, 2, 2, -2, -2, 3, 1, -3, -1. And then if I move b to down here, b was 3.31, -2.87. Now it's -3.31, 2.87. So again, just switch the signs. Oh, and one thing I just realized I didn't really specify about this the whole time. All of these rotations are about the origin, about 0, 0. That's where we're going to be rotating from. The center is at 0, 0. Now our last formula is if it's a 270-degree rotation. And really this one's a lot like the 90-degree rotation. The first thing you do is you, and it's again 270 degrees counterclockwise, about the origin, so about 0, 0, and you can see it here. It's 3 right turns, so it's like 3/4 of a circle. You now multiply the x value by -1 and then interchange the x and y. So you swap x and y, but the old x value becomes the new y, and you switch that one's sign. Okay. So again, here's the computer kind of showing you how to do that. So here's 270. So not only do we switch both from 3 to 4 to 4 to 3, but the old x was 3. Now the new y, which should be 3, is actually -3. 2, 2, that doesn't look any different because you just swapped the same numbers, but switch the new y to negative. 3, 1, 1, -3. And again, if I move like point C to something that was originally negative, notice, I'm sorry, let's do this way. Let's go left. Okay, if it's left, it's -3.39 for the x. Now the new y is positive 3.39. So again, switch the sign of that. Okay, so here's the first problem. We're going to take DGJTSR, whatever they chose that for, and we're going to rotate it 90 degrees counterclockwise. They want to know where would point T be after that rotation. Okay, so point T, we're going to have rotated this guy 90 degrees counterclockwise. So the formula for that, 90 degrees counterclockwise, is you take x, y, and you swap them, and that's what I always think of first, is swapping them, and then switch the sign of the y. Okay, so here is point T, right here. T is at 1, 2, 3, 4, 5, 1, 2, 3, 5, comma 3. Now what's going to happen is I'm going to switch those 3, 5, and then, okay, I'm going to switch the sign of the new, of the old y, which was 3, to the new x to be -3. It doesn't fit on my screen here, but it'd be at -1, 2, 3 right here, 1, 2, 3, 4. Be somewhere about here. And if I connected point T to the origin and point T out here, because that's where T prime would be, you can see it forms a right angle, and I've gone 90 degrees clockwise, or counterclockwise, excuse me. So 5, 3 becomes -3, 5. All right. All right, here we go. Next one. This is 270 this time. So instead of 90, it'd be 270. So let's see here. We got the same drawing. They want to know where point Q is going to become, though. What is point Q going to become? Okay, so there's point Q. So let's take a look. Okay, so a 270-degree rotation. So again, we have a formula for that. X, Y. We swap Y and X. But now instead of changing the sign of the new X or the old Y, change the sign of the old X, which is the new Y. So Q is at 4, 5. So it's going to become 5, 4. But now I'm going to switch the sign of that 4 to become 5, negative 4. And I'll do my best to kind of approximate it, which is, the answer is not one of these on here. That's weird. Well, let's go with C. That's the least wrong. Sorry about that. I'll have to make sure I fix that on the slideshow. That should be 5, negative 4. So anyway, if I look at that, we go right 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and down 1, 2, 3, 4. Trying to kind of approximate that. Connect it to there. Connect it to there. Okay, and so we can see that's about 270 degrees counterclockwise. Again, that's the initial assumption, is it's counterclockwise. And then we know it's 270 because there's 90 degrees and a whole circle is 360. Okay, here we go. That's it.